Greetings to SurFISO. My name is Yuwon-Sin, metric number 269660. In this video, we will present topic 3 comparative static analysis and the first questions of AL191. In this topic, we have economy models and need to solve for the equilibrium values of endogenous variables and see how the changes one of the exogenous or parameters variable will affect the equilibrium value of the endogenous variables. And we compute this by using the partial derivative. And use the partial derivative, we can get the total differentials, and I will talk in detail in these questions. Let's see to the questions. Let's see this G now here is related to the fiscal policy, the good market, so it's a IS model, and the monetary policy here is related to the money market, so it's a LM model. Due to this is a ISLM model, so we need to put them into the implicit form, which is equal to 0 or constant number, because it's the general functional form for the ISLM model, and we need to arrange the variables follow the sequence endogenous, exogenous as parameters. So YRE is the endogenous, G naught and M naught is the exogenous. Due to these no parameters, we just ignore it. Okay, we can start to take the total differentials of the functions. The total differentials means we need to sum over all the independent variables of partial derivative of the functions with respect to a variables and times the total differentials of that variables. So we can see the variables here, y is same and r is same, e and e is same. So we sum over them, you can gain the total differentials. The second and the third functions is follow the same process and the step to do, you can get the answer. And see, this is not G now here. Why is because we see to the third questions, we just need the effect on the endogenous of the M now. So we just need to by let the M now is not equal to 0, but assume that the other exogenous variables is equal to 0. So the G now is equal to 0, so it's nothing for the G now here. Also, we can do to the alternative notations, which this second way to gain the total differentials. We just need to put the d here and total differentiate the whole function. We can gain the answer. The YRE in here is subscript because it represents the partial derivative with respect to these variables, which is YRE. And the second and third, we follow the same step and the process. We can get the final answer. I finished my part. I will pass the next questions to Mei Ming. Thank you.
Get the same answer of the matrix form by using this the first question into a matrix of form. So before we start to form a matrix, so we have to arrange it endo and exo and parameter. So in these expressions, we only have exo and endogenous. So for the endogenous is this dr, dy, and also the de. So for the rest, we just like follow by these rules. Derivative of f1 respect to I star. So we would just arrange it again like according to the matrix form. So the next step, we will like calculate it. So the derivative of f1 with respect to the y star is actually 1 minus c subscript y and so on. So we just like find out all the derivative parts, then we write it again here. And for the m naught is actually -1, so we put it -1 here and we times together, we get a 1 here. So eventually we get an answer of matrix form here. So besides this way, we also have the second way to do it. So it's more likely the same, simple than the first method. First, we have to find out the derivative of the y, the dy. So it's referred to here. So you can see the y minus c, we will get 1 minus c subscript y, which is this. So and so on. So eventually we will get the same answer of the matrix form by using this method. Yeah. So now I will pass to the next candidate, Sesian.
I'm on Shishan matrix number 271502. For this question, first we have to find the Jacobian determinant. Let me start with 1 minus cy. So we have to eliminate the first row and first column, then it will left LR0 FRXE. And then 1 minus cy times the determinant of 2 by 2 matrices, then minus negative IR, then eliminate the first row and second column, we will get LY0, 0XE. And then plus negative XE, eliminate the first row and third column, we will get Ly, Lr, 0, and Fr. And then we times them, 1 minus cy times the determinant for 2 by 2 matrices, which is AD minus BC, then we will get LRXE. Same with these two, Then we will get plus IR times LYXE minus XE times LYFR. Then we will get negative, which is not equal to 0, which means non-singular. And then to find the effect on Y if monetary policy happen, first we have to, by using Cramer's rule, we put P into first column to find the effect on Y. Then by using the same way with this one, we will get the determinant is IRXE minus XEFR. And then to find the effect, J1, this one divided by OV Jacobian determinant, which is this one. Then we will get the positive relationship between Y and M now. And then for this one is to find the R with M now, relationship R with F now. So we put P into second column, and then by using the same way, we will get the determinant is 1 minus CY times XE. Then also same, find the relationship. We use this determinant divided by OV determinant, we will get the negative relationship. R with M now is negative relationship. And then for third one also the same. We have to find the E relationship with M now. So we put B into third column. Then by using the same way, we can get the determinant is Y minus CY times negative FR. And then divided by ORI, we will get the positive relationship. Next, we pass to Putri.
Okay, Assalamualaikum. My name is Putri Norazira binti Muhammad Rozni. My matrix number is 275646. Okay, so today I will present about question number 4, which is comment your finding in question number 3 above. I will comment about these 3 things, which is this one, and this one. Okay, for the first one, MO and Y is positively related, which is if MO increase, the income equilibrium will increase by this one, and vice versa. And for the second one, MO and R is negatively related, which is if MO increase, the interest rate will decrease by this one, and vice versa also. And for the third one, this one, MO and E is positively related, which is if MO increase, the interest rate will decrease, which is the ringgit Malaysia will depreciate. For example, $1 is equal to 5 ringgit Malaysia, will depreciate to $1, which is equal to 6 ringgit Malaysia. It leaves exchange rate equilibrium increase by this one and vice versa. Okay, that's all for my comment for this question number 3. And for the conclusion, we have discussed about topic 3, which is comparative static analysis by using 2 methods. What I can conclude here is the exchange of exogenous or parameter variables affect the equilibrium values of endogenous variables. Okay, that's all from us, Group 10. Thank you so much.